Let's compare the growth rates of logarithms with other functions. So here we see the exponential function 2 to the power of n grows a lot faster than a linear function n, which grows a lot faster than log n for large values of n. And note that in computers, we imply that the base of the log is 2. And here are some examples. 2 to the power of 0 is 1, 2 to the 1 is 2, and so on. So noting that the log function is the inverse of the exponential function. So for example, when we have 2 squared is equal to 4, and if we take the log of both sides, so we have log 2 squared is log 4, and applying the rules for logarithms on the left hand side, we get 2 log 2 is equal to log 4, and log base 2 of 2 is 1, so we obtain log 4 is equal to 2. And we can see that log 1 is 0 because log 1 is the same thing as log of 2 to the power of 0, which is 0 log 2 by the rules of logarithms, which is 0 by 1 or 0. And similarly, log 2 is 1. And from the graph here, we can see that log n increases as n increases. And also 1 is less than or equal to log n for n greater than or equal to 2. So remember that log base 2 of 2 is 1, and that's going to keep increasing, so log n is always larger than 1 for n greater than or equal to 2. And therefore we can conclude that log n is always less than or equal to n for all n greater than or equal to 1. And you can see that from this table here, that log n grows a lot slower than n, starting from n equals 1. Please subscribe, like and comment to help me reach more students.